Hello, welcome back to the class. We're on the last part of importing and exporting data with R, and this time we're going to focus on SPSS data. So SPSS is similar to Excel in that it's proprietary software that stores data in a very specific format and provides a graphical interface useful for even deeper analysis. So it stands for Statistical Package for the Social Sciences, and it's owned by IBM. It's very expensive, and usually only large businesses or organizations own licenses. But it's possible to bring in data saved by SPSS into R. In this example, we'll be working with case-level data from the FBI's Supplementary Homicide Report. It has data on more than 27,000 homicides and was obtained via Freedom of Information Act by the Murder Accountability Project. We'll be going deeper into the project and their goals and what they're into later on in the course. I have a link to a New Yorker article in the walkthrough. It's definitely worth reading. So the data, let's take a look. I'm currently in the right directory. It is 25.6 megabytes zipped. But unzipped, let's see how that looks. That is a almost 200 megabyte file. If I tried to open that in Excel, it would cry. But R can handle big data, to some extent. Data is saved to the computer's memory. So if your computer's memory is 16 gigabytes, then that's the max file size you can import. I don't recommend pushing it to that point because it still takes up a lot of memory to run R functions. If I get to the point of working with big data that size, then there are strategies like putting data into maybe a MySQL database or even like flat files like MongoDB or something. But this is as big as it's going to get, all right, that we're going to deal with in this course. So first, download the data and unzip the data, which I've already done. There's some commands in the walkthrough for how to unzip data in R that I've included if that's what you would like to do. If it's already in the data directory, like it is here, we can now run the function read.spss. And this is part of the foreign package, which you need to install and run. So I'm going to load that because I already have it on my system. Oh, I guess not, so let me install it. Great. Now I can run the library. That's why. Typo. Okay. So, there's a couple of specific variables we need to deal with for dealing with SPSS files, because SPSS files kind of does this thing where, remember how R does this weird thing with factors? It has things like it stores things numerically, but the string of it is a whole other thing. That's similar to what SPSS files does. So I'll show you an example. So let's bring in this first file. I'm going to call it the data labels and read.spss. Pointed to data slash, that's where it is, right? Data slash shr76 underscore 16 dot sav, and pass it to data frame equals true. So this means I'm taking this data, this SPSS file, and I wanted to save it as a data frame in R. This is going to take some time to load because it is 200 megabytes after all. Okay, now you see there's some warning messages about length of strings and the column names and stuff. We can ignore that. I've worked with this data before. I'm okay with ignoring this warning. Ooh, look at that. It brought in 750,000 cases, and it's got 33 variables, so that means 33 columns. Check this out. Okay, so that's how it looks with the labels. So let's bring it in one more time without the labels. I'll show you how that looks. So data I called labels, and now I'm going to bring a new data frame from spss called data only. Same thing as above, read spss string data /shr7616 sav, and this time I'm going to use the variable use.value.labels equals false. Let it run for a minute or two. Okay, whoa. I also need to give this a data frame. Let's try it again. There we go. So it's no longer a list, it is now a data frame. So let's take a look at these next to each other and see if you can spot the difference.
Andrew, hello.
Hey, Marty. Okay, nothing here. Okay, can you see this? You've got agent type, we've got the number here, and we've got the value here. We've got solved as a number instead of yes or no. What else? State name is, no, that's right. Oh, month is spelled out January under labels, and it's used the number for month. Now this is fine because we're going to be dealing, often you would just want to deal with the labels, right? But we're going to be using this data specifically in a way that requires those values without the labels, because we're going to be using an algorithm that the Murder Accountability Project has developed to detect serial killers and whatnot. So what we want to do is take these data sets, these two data frames, and bring them together, preserving both the labels and the values. So we're going to use, and we're going to go in this later on in the next chapter, but for now I'll just show you right away. We're going to use the dplyr package, and I kind of already know which labels are to keep and which ones are different. You can just browse both of them. You can type in call names, data labels, etc., and kind of go through line by line, column by column, variable by variable, to see which ones you want to keep, which ones are the same, which ones are different. And so I know that we're going to keep ID, county FIPS. Okay, that's bad. ID, county FIPS, ORI, state agency, and then everything else is kind of sort of different. So I'm going to copy and paste the code in because this has been a long chapter. So let me break down what's happening here, and I'll go into this in more detail later on, but I'm creating a new data frame called new labels, and I'm selecting from the old data frame data labels, and I'm keeping these particular columns, ID, county, FIPS, ORI, state, agency, etc., and I'm keeping these other, and I'm renaming the rest of the data frames. So you see, oh well, except for year. So if there's anything to be renamed, then I've renamed it by doing equals. And the label on the left is the new label on the right is the old one. Okay, so I can do this, run these lines of code, and I've got new labels, and that's how it looks. So you can see the difference is now I've added like specifically underscore labels so that this knows that it's a label, because what happens is I'm going to want to bring them both together, have them side by side, and know the difference between value and label. So okay, so I've got a new data frame for new labels. I'm bringing a new data frame for data only. So let's copy and paste that over here. You can also run that literally through the RMD files here next to it. So I'm going to run that. Okay, so what I want to do is I have two data sets, one with data only, one with labels. And you can see the one with data only is less because there are a lot of repeat values, right? Like year, victim age, and I've kept that off because as long as it exists in one, it doesn't need to exist in the other because when I bring them all together, I don't want duplicate columns. So how do we bring them together? We use a function called cbind. So create a new data frame called new data, cbind, and bring those two data frames together. New labels and new data only. Now this only works if the rows are similar or the same. The same. If it doesn't line up, then it'll give me an error. And it did not give me an error because everything is perfectly lined up. Thank goodness. Okay, so now I've got new labels. I'm sorry, new data is the new combined data set. You see 47 variables. That's a lot of columns. So I want to, right now they're all spread out, like label is all on one side and values are on the other. I want to keep things grouped together, like labels and volumes, labels and values, labels and values, if it's like MSA, if it's weapons, whatever. So I'm going to have to do the select again. So I'm copy and pasting this over. You see the select function. And this time I am listing out in order the columns that I want in what order. This time I'm not renaming them, see, because I've already renamed them. So now source label is next to source value. Solved label is next to solved value. Year, fine. Month label, month value, etc. So let's rerun that. New data is new data. And it's nice and clean. We've got homicide label next to homicide value. Labels are next to values where, for me, that's where they need to be. Just so it's easier to handle things. Because, 47 variables is a lot. I don't want to have to dig around. So at least this makes things a little bit easier. So, in the meantime, I've got so many rows. What is that? 750,000 times 5. So I've got like almost 4 million rows of data here. That's taking up a lot of space in my memory. So I'm going to clean that up by removing them. Okay, that's all I need. This is a great transition to the next piece of wrangling data. We're going to be using this, all these murders and cases to go into wrangling data and transforming it and analyzing it in the next chapter. So, I feel like we're all set. I hope you feel good about this. We've gone through a bunch of chapters. There's a lot of types of data to import, and they're all very important. And now you know how to deal with the really big ones. All right, see you in the next chapter.